One of the sources of contamination you can get is when you work with dirty nitrogen. And as you can see, when you have nitrogen that is in a drawer for this for a long time, you see that it will catch a lot of water that turns into small ice crystals that you can start to see floating around in the liquid nitrogen. So if we would use this liquid nitrogen in our Vitrobot or also to mount samples in the microscope, we have a high risk that all these ice contaminations, and these are the ones you can see by eye, those are very visible. And since you can see them by eye, they're going to be extremely big in a microscope. But you can be very assured that when you see contamination by eye, there's other crystals that are smaller that are also in there that will also be present on the microscope in the order of 200 to 500 nanometers. So whenever you're working with dirty nitrogen, be aware that this can attach to your grid and greatly hamper your possibility of getting good data sets. Now, the sources of contamination while preparing the grid with liquid ethane are first also the ethane itself. Now, you can buy several qualities of ethane, and most of the time they're indicated with a number being 1.5, 2.5, 3.5. And that number means the first number, the 1, the 2 or the 3 is going to be how many 9s there are, and the 0.5 is where the 5 will be. So 2.5 is going to be 99, 2 times 2, 99.5% pure ethane, and 3.5 is 99.95% pure ethane. We normally use 99.95% pure ethane, so the 3.5 grade. This is much more expensive than the 2.5, but the ethane itself is, if you use 2.5, can be too dirty, and the contaminants in the ethane that are still left in the ethane can be deposited on your grid. So you will see carbon type contaminants on your grid. Then you also have solid ethane that can be deposited on your grid. We have seen that when the ethane comes into contact directly with liquid nitrogen, and as you can see here, there's these large chunks of ice, or that look like ice, but look a little bit like snow. This is actually not ice, not water, but this is solid ethane that is formed. Also, that can be attached to your grid, and when you use a side entry holder, when you insert the holder in the microscope with the airlock, in most cases not all of that ethane is evaporated away, and you will still see that. When you have an outer loader based system, when you load a sample, the turbo pump will pump the outer loader, and that actually will cause the ethane to sublimate. So the solid ethane for outer loader based systems is not anymore a source of serious contamination. The ethane on the nitrogen on the outside, however, is. So again, if you're using dirty nitrogen by refilling your system, then you'll bring these ice crystals into the area where you store your grids. Also, if you don't refill, but if you spend a long time freezing samples and using this tray for freezing 8 to 12 samples in a row, the longer you use this, the more chances you will get that actually the liquid nitrogen itself gets contaminated simply by the time it takes for you to freeze. The next form of contamination comes from the anti-contaminator ring. There are some labs that actually don't use the ring at all. I would advise to always use it, because you can see that at the surface of this ring you'll see some vapor layer being formed. And this is the interface between the warm air and the nitrogen vapor. Now, nitrogen vapor is cold, and there is no ice in nitrogen vapor. So nitrogen vapor is actually very, very clean. And the moment you go through that interface, that's where you will pick up small ice crystals, because this mist that you can see here are actually small ice crystals in the air that can contaminate your sample. So also the interface between the nitrogen vapor and the air is a source of contamination. And the lower your liquid nitrogen level is in your tray, and the lower this anti-contaminator ring comes, the closer it comes to your sample and the more chances you will have to get a source of contamination from that. So to sum up, the source of contamination coming from the vitrification process can be large ice crystals that come from dirty nitrogen that are floating around, and they can be visible by eye, and then they're very, very large. Or they can be smaller, the ones that you don't see but are also present there. You can have finer ice crystals. Normally they're round, they're not faceted in the microscope, and those come actually from the vapor. So the longer you keep the grid here in the vapor, the more chances you will have that you will pick up that. So that's a fine contamination of small particles, normally round, grouped together. The nitrogen contaminations are big faceted crystals that you can often see in the microscope. And finally, the ethane, that is indicative of it being burned away very quickly. So when you have the electron beam on ethane contamination, you normally see that it pops away instantly. But again, in autoloader based systems, this ethane sublimates when the turbopump comes on, and that contamination is normally not seen anymore.